Okay. Yeah, we're mainly talking about materials. Um, Again, variety, different material kinds, depending on what you're wanting to get out of your part. So I'm just going to be going over a couple of them today. There's definitely a lot more out there than what I'm just going to be talking about right now. Um, I'm going to be mentioning some stuff that isn't on here, but in general, this will kind of give you a taste of what's out there. One of the most common forms of material when it comes to FDM 3D printing is a material called PLA. It's technically biodegradable because it's made from corn. It's a corn-based polymer. So that's pretty cool. I say biodegradable in like heavy quotation marks because it needs very specific conditions for it to break down. But in technicality, it is like biodegradable. But one of the main reasons why people like using it is because it's really cheap, it's pretty easy to print, and there's a really large variety of PLAs out there, mainly around like colors and different and stuff like that. Partially because so many people print it, lots of manufacturers like offering different colors, but PLA in general is a pretty great material. It's actually very rigid for um, like the material. It's very strong and like resistant to like bending and stuff like that compared to some of the other materials we're going to go over today. But its main downfall is that its melting temperature and glass transition temperature is very low. So that means if you like expose it to any kind of heat, it will tend to warp and deform over time. So like its print bed temperature, you can technically print with no print bed or like with no heat on the print bed. But people normally print around like 60 degrees C for the print bed because it's around the glass transition temperature. But if you were to leave your PLA part inside like a car on a hot summer day, the heat inside the car can warp the parts, right? So, sometimes that's not ideal if you want stuff to not bend and warp over time. But if it's in like a climate controlled environment, like on your desk or something, PLA is usually a pretty good choice, just, partially because it's so cheap and it's so easy to print. So that's why it's really popular. It's a pretty great material, but the main downside is its low temperature resistance. ABS is kind of on the other side of the spectrum where it's a little bit, it has a lot higher temperature resistance compared to PLA, but in terms of ease of printing, it's a little bit harder to print because it requires such high print temperatures. It can tend to also warp when the print cools down because you're putting in so much heat into it, and then once it cools down, it'll contract and then it'll warp. So ABS or a variant of ABS called ASA is on the more difficult side to print because of that. But with better machines, it's kind of becoming easier and easier to print. ABS used to be really popular because it was super cheap, and it's still pretty cheap because ABS is used in a lot of things for injection molding. So I can like guess that like this monitor or lots of other pieces of plastic around you are probably made of ABS. I know for a fact that Lego is made of ABS as well. So like it's a very common material, but it can be a little bit harder to print. ABS and ASA is actually the material I print most commonly, but it's mainly because you see this machine here. It's got a lot of stuff like I've modified this machine a lot to make it print ABS and ASA very reliably and very well. Um, One of the things that it needs is a high chamber temperature. If you can keep the ambient temperature warm, then as the print cools down, it won't cool down as much, so then it won't warp as much. So you can see how I added insulation and stuff like that to increase the chamber temperature and make sure or make printing ASA and ABS and stuff like that easier. So a lot of like harder to print or higher temperature or like engineering grade materials kind of require a fully enclosed printer, like something like this. But open frame printers like I don't know, Prismark 3 or Prismark 4 or like the Bamboo A1 1 series. Like those are typically geared more towards PLA and like PPG, which we'll talk about in a little bit. I'm going to pass this spool around. This is a spool of ASA, and if you didn't know, filament comes on spools like this. They're typically 1.75 millimeters in diameter, but sometimes they can come in 2.8 or 3 millimeters, I think. But yeah, feel free to pass that around the room. I have a couple other filaments on hand that we can pass around as well. But yeah, as you can see, there's a lot higher temperatures that are required to print ABS. But I like it a lot as a material. It's very strong and very heat resistant. I've printed ABS parts and I put them inside the engine bay of my car, and they've held up for like several years, and they're still holding on strong, which is kind of a shock to me because I want them to die so I can replace them with like better materials. But yeah, it's a pretty great material, and it's very common. So yeah. One thing to note about ABS is that it smells really bad when you print it. A lot of these materials, well, actually, all of these materials will kind of emit some kind of microplastic or particles and stuff like that. So you definitely want to print in like a like ventilated area so you don't breathe in microplastics, and then that's probably not good for you. So I have like an air purifier set up at home. I don't have it today, but like this is a pretty big room, so we should be okay. But in general, you want to print in a pretty well ventilated area. But yeah. The next material I'm talking about here is PTG. PTG, in my opinion, is kind of like a middle ground between an ABS or a PLA. It's a little bit easier to print compared to ABS. It doesn't require as much heat, but it's a little bit harder to print compared to PLA. Most printers today can print PTG with pretty relative ease, but PTG used to be a little bit harder to print. One of the main notes about PTG is it's very hygroscopic, which means the material will absorb the moisture in the air and it'll like get into the filament. And if you print a spool of wet PTG, the moisture will actually boil out of the nozzle as you're printing it, and then you'll get really bad surface artifacts, like your prints will look really ugly. So if you're printing in a more humid environment, like sometimes it rains a lot here, and then the like spools will absorb water. You want to dry them. So on the top of my printer is I have a dryer, so it basically heats up the air around it to kind of dry out the filament and make it better to print. You'll see that a lot of other materials are hygroscopic on this list as well, but PTG is probably one of the more common filaments that you'll find that need drying. If people ask me like, "Oh, why my print's really bad?" And I'm like, "What are you printing?" They're like, "PTG." I'm like, "Have you dried it?" And they're like, "You have to dry it." I'm like, "Yes, because you should dry it." So dry your PTG if it doesn't look good if you're printing stuff. In general, I liked PTG a lot. This was my main material before I kind of switched to ABS and ASA. And I liked it a lot mainly because of its higher temperature resistance compared to PLA. I'll show you a little bit later, but I have stuff that's printed out of PTG, and I've like left it in the car all summer, and like it had no issues at all. So I really liked PTG. There's a lot of wide color selection too if you're interested. But yeah, it's a pretty good material. Compared to PLA, it's a little bit more flexible, so you could say it's a little bit more impact resistant. It tends to bend a little bit before it breaks, where PLA tends to like shatter. Again, depending on what you're going after, you might want something that bends a little bit before it breaks, or you might want it to fail or be more rigid like a PLA. So again, there's no best material. I just have some material preferences, but it really depends on the application that you're going after. But yeah, that's PTG. iPhone. Oh, yeah. Um, okay. So the next filament here is kind of a unique one. It's called TPU. It's basically a thermoplastic that is really flexible. So you just saw the spool of JSA that I passed around. Pretty standard. It's not super like super stiff, but it's also not super bendy. This is a spool of TPU, and like you can bend it on itself and it won't break at all. So it's very interesting filament. I just started kind of using it, but I find it very interesting. Obviously, because of how flexible it is, it's extremely impact resistant. My roommate last year uses, or he has a test for me whenever I try a new material. Every time I print a new material on my printer, I'll print a benchie, which he did last week, and then I'll give it to him, and then he'll throw it on the ground as hard as he can, and that's his test for how good a material is. But I printed a benchie for him out of TPU, and it just bounced all over the walls. So it's pretty funny. It got him kind of frustrated that he couldn't break it. But it's a very interesting material. Um, One interesting application for TPU is that people print like TPU gaskets for stuff. Like I made like enclosures for small like electronics that need to be sort of waterproof. And then I printed a TPU gasket in between like an ASA shell, and it did pretty well in terms of like keeping water out. So it's pretty interesting. You can do a lot of really fun things with TPU. Um, some things that people are doing a little bit more often now because printers are getting better is that they're mixing rigid and um, like soft materials. So this printer might have trouble doing it with a single tool head, but a lot of or some new machines will have multiple hot ends, so multiple sets of extruders and stuff like that, and they'll switch between one another so you can mix like a PTG and a TPU or like a PLA and a TPU. And you can, if you design things properly, you can have a single part made of multiple materials that has flex in areas where you want it and is rigid in other areas. So people make like single piece hinges and stuff like that with the mix of TPU and other things. It's very interesting. But yeah, it's kind of fascinating to me. But it's a little bit hard to print in the sense that the filament path can be a little bit more difficult. Um, because it's so flexible, if you have an unconstrained filament path in your tool head, the material itself will like spiral inside of the tool head and get caught. It's less of an issue now because people have designed better tool heads. That used to be a really big problem for flexible filaments. Also, TPUs come in many different like flexibility ratings. They're called shore hardness. So I believe that one's 95A, but you can get different amounts of like softness depending on your application. So yeah, it's pretty cool stuff. The next one on this list is nylon. We're kind of getting more towards engineering grade materials. These are a lot more difficult to print because you can see that it requires temperatures quite a bit higher. I think everything beyond this kind of recommends at least like a chamber or fully enclosed printer at the minimum. So yeah, nylon's pretty good stuff. Very tough, but it has a tendency to warp a lot. So what people have done is they mix nylon with carbon fiber to get carbon fiber nylon, or they mix glass fibers to make glass fiber nylon. They'll basically take little tiny chopped carbon fibers or pieces of glass and they'll mix it in a material. That'll both add rigidity and also prevent warping because the material is more rigid. To print stuff like this, you need to make sure your printer is equipped to handle abrasive materials because carbon fiber and glass fiber will shred through your nozzle if they're not hard enough. So lots of standard nozzles are made of brass. So if you print a carbon fiber material, it will just basically grind away at the brass until you have like a bigger nozzle size than you actually want, right? I printed with brass and I printed like one carbon fiber part and the hole was like 0.4 when I started and when I took it off it was visually like quite a bit larger. So you definitely want to use some kind of harder material when you're printing a carbon fiber fiber material. This printer has a carbon steel nozzle, but I also have like tungsten carbide nozzle like that. So it gets pretty fun. So this is a small sample of my carbon fiber nylon. It's pretty cool stuff. It's pretty temperature resistant. One thing about this is that this is more material science stuff, but to get the best or the most out of this material, you're going to want to anneal it after you print it. So after I print my carbon fiber nylon parts, I basically put it in a little oven and bake it for like 6 or 8 hours at a specified temperature. And then baking it at that temperature will release all the internal stresses that come out with 3D printing, right? Because of all that thermal expansion and contraction, there's a lot of internal stress that makes the part weaker. But if you anneal parts, they can get a little bit stronger. When you do that, the parts warp a little bit, so you can do stuff to like compensate for it. So the parts will actually end up shrinking a little bit. So when I print it slightly oversized, and then I anneal it, and then it shrinks down to size. This is like kind of technical stuff. It's kind of what I've been exploring most recently. I've been modifying this, but it's a lot of fun. The tool head on this printer is actually made of carbon fiber nylon. But yeah, one of the downsides to a nylon or a lot of these more engineering grade materials is like PTG, they're extremely hydrophobic. Nylon in particular is very, very susceptible to moisture. Very much so, in fact, that you basically have to exclusively print while actively drying the filament. Sometimes when you print PTG, you can dry it and leave it out for like, a couple weeks or maybe a month or so and print it and it's fine. But then for like a PTG, that's not really the case. I mean, for a nylon, that's not really the case. It can absorb moisture in a matter of like hours. So if you're printing nylon and your prints suck, then you should dry it. But yeah, again, you can see these requirements are getting a little bit more stringent. They're harder to print, but if you can get a nice nylon setup working, it's pretty awesome. I think this is the last one on the list, which is polycarbonate. Polycarbonate is a very, very strong material. If you weren't aware, polycarbonate is one of the materials they use to make bulletproof glass. So it's definitely, a pretty good engineering grade material, but you can 3D print it. There are polycarbonate blends out there on the market that have some percentage of polycarbonate in it. Those are a little bit easier to print compared to pure polycarbonate, but pure PC is pretty difficult to print. You can see these nozzle temperatures are kind of climbing up there. If I was to print PC, I'd probably print a little bit hotter than that. But yeah, this is just kind of here to show you that there's a lot of different material selections when it comes to 3D printing. And a lot of these benefits come from the injection molding industry because they both use thermoplastics, heat them up, and extrude them. We just extrude it in a different way to make 3D printed stuff. So we kind of benefit from the injection molding industry, which is kind of interesting. But yeah, kind of putting all the graphs on top of each other, you can see how there's a wide range of, materials and different abilities that they kind of possess. So when you're making stuff, picking the right material for your job might be something that's more important to you if you're making more functional parts. But yeah, any questions? I know this is a lot of technical jargon, but I hope this is at least somewhat interesting to you guys. Yeah. All right. In terms of resources, there's a lot of 3D printing services at Purdue and around Purdue. I think some of these links don't work anymore, but there is a 3D printing club at Purdue. If you need things printed, you can definitely go to them for help. I'm sure some of you might know someone with a 3D printer. In fact, you do now because you're sitting in this class and have a printer. So if you ever need stuff printed, you can feel free to reach out to me. I've got plenty of printers at my disposal. But you can also go to clubs and other resources at school too. So yeah, it's pretty cool stuff. Also, if you want to buy a printer, feel free to ask me. I can see if I can find you some recommendations, because having your own printer is also pretty fun. But yeah, any questions about this 3D printing in general? All right, how's it going? Why don't you, did you delete everything else? Did you delete all the other Wi-Fi credentials? Okay, maybe just delete them and just do my phone. Well, I don't know if you formatted it correctly because there's some weird format for more than one credential. So just do one. But yeah, anyways, with that out of the way, we're going to be covering rendering, which is the final part of your final project. I hope that you've all at least started on your final, but if not, that's okay. You still have time. If you were wondering, I sent a message out, I think yesterday or a couple of days ago. Your final project is due at midnight, not today, but next week. So on Monday at midnight, that's when your finals are due. And then I'm going to start grading. So yeah. Again, you've seen this slide before. This is just kind of the general criteria for the final. It's not too bad. This is something that you should all be able to do at this point. Obviously, not something that we've made in this class previously. You need at least 5 design features. We've talked about this. And then it must be designed with manufacturability in mind. So if you're paying attention last week, that should be a lot more doable now. But yeah. Any questions about this? I've said this like a couple times, so I'm guessing that most of the questions are kind of good. Yeah. All right. Awesome. Okay. So this is basically the last assignment that I'm going to cover in class. We're going to be rendering some of our final projects, or in this case, we're going to be rendering something that we made in class. So there's basically 2 renderings I'm going to want you to do for this week. The first one is going to be the one we're doing right now in class. So that's just anything that you model in this class. And then the second one is going to be a render of your final model. So please submit 2 renderings. I'm going to walk you through how to render it and how to, exactly what to submit me, because people have sent me screenshots and stuff like that of certain things. And I'm like, no, that's not right. So I'm going to show you how to properly render stuff and then how to submit it. But yeah, basically for renderings, typically, we'll be modeling stuff, we'll be finished with it, and it looks great or it looks maybe a little bit boring. But if we want to present our work or just kind of show it off in some kind of way, a lot of people like to make renderings of their stuff. It allows you to kind of put it in an environment, apply textures and stuff like that to make your parts or assemblies look more professional. A lot of ads for different products online typically use renderings instead of an actual product to generate, the model of whatever they're selling on the computer, and then to have it fly across the screen and stuff like that. So today we're not going to be doing animations, but we're going to be covering a basic still image of a render of your part. So yeah, first things first, just going to open Fusion, and then we're going to open some kind of part that we made in class. So, you can do the Lego car or something like that. Okay, I was working on this earlier, but are you in the way? Oh, no, you're good. Yeah, you can take it out. Okay, 1 second. Okay, so just pick something that we've done in class already, preferably something with an appearance. If not, you can apply appearance. I'm just going to start with assignment 1 here because I think that these should have appearances. Yes. So you can see here, let's say I finished modeling whatever I need to model. I think this looks good and I want to render it. We've basically exclusively been in this design workspace up here, but you can change it to, a couple of different things. One of them is rendering, but there's also simulations and stuff like that. If you're interested in like simulating stuff like that, there is an FEA course that we offer. It's actually run by my roommate. So if you're interested in FEA, you can take his class next semester. But today we're just going to be going over rendering. So over here, I'm going to go into this rendering workspace. You'll see the environment changes. The lighting gets a little bit different, but you can see our models are still there. There's a nice gray background that we're going to change in a second, but this is your rendering workspace. You can see it looks a little bit different. The tools are a little bit more limited, but this should be everything you need to render stuff. If you're looking to apply appearances, if you haven't done it already, there's a button here, or you can just press A for the shortcut. Like I showed on week 1, you can just drag and drop materials or colors and stuff like that. But to configure our workspace for what we're going after, we need to change this background. It looks kind of boring, but we want to make it something a little bit more nice and maybe slightly more realistic. So over here, there's a scene settings button right next to the appearance button. If you open that, it'll present you with this thing on the side. You can adjust the brightness. I'm going to leave it as it is. There's a background. In this case, it's set to solid color. What we want to do is we want to make sure we change this to the environment setting. Basically, we're going to apply an environment so it looks like it's kind of in the real world. So make sure you change this to environment, or else when you select an environment, it's not going to show up. So environment, it changed a little bit. And then we can go into our environment library and then pick something. For this assignment, I request that you pick something that is not like a flat or plain background. That just kind of shows me that you know how to apply an environment, because sometimes if you just choose like the cool light one, it's kind of going to be hard for me to know if you just changed it or not. So please pick something with like an actual background. I tend to like to use, oh, I can't find it right now. Oh, there it is. I'll pick Plaza. So Plaza right here. If I click on it, the computer will think a little bit, and then you can see the background has like these cobblestone textures. I forget exactly where this is in real life. Someone in last session told me, but I forgot. But you can kind of manipulate your part around to kind of orient it in a direction that you like for rendering. You can also like zoom in and out. I think you can move it with this position. Yeah, just like this. But yeah, once we have our environment applied, I'm just going to close this. And now we can start to render. There's a couple of different ways you can go about rendering. We can kind of get a render preview by doing kind of a mini render locally on the computer. But for our final renders, we're going to send it out to the cloud, which is something that Autodesk offers students for free. But before we do that, I'm going to use the in-canvas render feature. It'll basically create like a preliminary render that I can use to test. And it'll kind of show you how rendering works in general. So if I click this button, the computer will start thinking. It'll get really blurry, and then it'll slowly get nicer and nicer, right? Basically, how rendering works is it'll take a pixel, and then it'll subdivide it into like smaller pixels, and then it'll keep doing that over and over again until you get a really, really highly detailed photo. So basically, the longer you wait, the better the rendering will get, because it'll subdivide pixels more and more. But, at the beginning, it basically starts at like 1 pixel. So with the in-canvas render, if I try to move around, you'll see it'll get really blurry because it's trying to render something while it's moving. But once it's still, it can continually subdivide and make it really nice. So you can see this looks pretty good. If I rotate it, my computer will lag, it'll get really blurry, and then when I let go, it'll start subdividing, create a more nice photo. So that's basically how rendering works, but this kind of takes a good amount of computing power, and if you're like me and you have a potato for a computer, rendering can make your computer sound like an airport, or it'll just take forever. So one of the nice things, like I mentioned earlier, that Autodesk offers to us students is cloud rendering. So basically, you can send your model out to the Autodesk server. They have a bunch of beefy computers. You can send the file out, they'll render it for you, and then they'll send it back to you. If you have a powerful computer, sometimes it's faster to do it locally, but I'm going to show you how to do it on the cloud. So yeah, let's say I'm satisfied with this orientation right here. I think this is kind of the direction I want to go for my render. There's this teapot here for the final renders. I'm going to hit this. There's a bunch of parameters you can change. I usually just leave it as is, but if you want to change the size of your render, this is where you adjust it. In this case, we're using the cloud render, but if you want to, you can render locally, or just maybe take some time depending on how good your computer is. And then for the quality, I usually set it as final, right? For making final projects, we want these to be really nice. But if you wanted something more rough, you can use the standard one. But I'm going with final here. You can see here we have unlimited cloud renders because I'm under the assumption that everyone has their education license working. Again, if it's not working, then just let me know. I can help you out. But you basically just press render and you're done. So we have these settings. I'm going to press render. It'll send it to the cloud, and then it should pop up in your rendering gallery. So right now, you can see it says it submitted a few seconds ago, and then it'll kind of go out, they'll render it, and then they'll send it back to us. But yeah, that's basically how it works. Now we just wait for the rendering to come back, and then I can show you how to download it, because some people forget that you can download these things. But yeah, that's basically it for rendering. Pretty straightforward, nothing too crazy. Any questions? No? Okay. I can walk around the room for a little bit, but yeah. I'm sorry there's not a lot of photo ops today. It's a pretty chill day for the last week. But yeah, that's basically it. So yeah. Does anyone have any questions about this? Oh, yeah. Um, your blur is up kind of high. Change background also. It's fine.